Hey, it's time again. This time I want to talk about drills, drill drivers, impact guns, and hammer drills, and rotary hammers, and breaker hammers. That's a lot of ands. And. Okay, so I got a couple sitting out right here. Let's see. Quarter-inch impact driver. This is a hammer drill. These are both fuel. So, and I got some schematics drawn here. I'm going to, we'll get to that. So let's start with the impact gun first because it's going to be the simpler one to explain. This is used for fastening and sometimes drilling. Quarter-inch quick connect chuck, pretty self-explanatory. 18 volt, this particular one, forward and reverse gear. This one's got multiple settings on it. Those are speed settings, and the last setting is for setting 4 is for self-tapping screws. Basically, it lets the drill run wide open, and then once it hammers one time, the torque backs off so you don't strip it. What model is this? This particular one is a 2853-20. This is the bare tool. Some of them are simpler. They may not necessarily have those controls on them. This is one of the fancier ones they make. It's a pretty nice tool. So how does this work? How it work? How it do? So pretty simple. This is schematic, very crudely drawn, but this is enough to give you the idea of how an impact driver works. So you've got an anvil. It's a piece of metal with two strike points on it. And you've got a hammer that has matching points on it. This hammer is attached to the motor, or I might have that backwards, but anyway, what happens is this system is all balanced and with the harmonics. It takes a ton of engineering and a ton of math to make all these spinning bits work together, but essentially what happens is this whole system is under spring tension, so that the anvil, it sits this way right here, and it spins. So it hits, the hammer hits the anvil, and that's what gives you that clack. That's what gives you your power. And then just a moment right after that, because of the torque in this system, because of the way they designed it and all the harmonics and all the engineering and all the math that went into it, this whole system's under spring tension. So what will happen is all that the sudden increase in torque will overcome that spring tension holding this system together. The hammer will rise and it'll skip over, and then it'll come back around again. It'll hit, things will move a little bit, it'll come up, come back around and hit again. That's what gives you that distinct clack, 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 clack whenever you use a impact driver or an impact gun. That's basically it. These are really good for fasteners. You can drill with them, but they're not really meant for drilling. The biggest thing to be careful with these is actually snapping your fasteners, especially on the higher settings. These modern, especially the brushless ones like this, the high-end ones, produce a tremendous amount of power. Probably more than they need to be honest. I mean, you can drive some pretty serious lag screws with something like this. But mechanically, they're actually pretty simple. There's not a whole lot to them. Most of the controls are electronic. This push button controller here. There's a brain box inside of here that basically tells the AC motor, and I'm going to do another video explaining why this is an AC motor and not a DC motor. It's because it's brushless. We're gonna talk about that. Don't worry, we'll get there. But all the switching, all the speed control, it's all electronic. So it's, mechanically, as far as actual mechanical components, this thing's fairly simple. But there's a lot of brains inside of here. So whether that's a good thing or not, it really just depends on your mindset. Me personally, I think as long as the electronics are up to snuff, it's fine. It's progress. So drill driver. And which one are you? This is a 2804-20. Okay, so drill driver. Okay, so let's talk about what drill driver means. Okay, so you can have drill onlys, you can have driver onlys, and you can have drill drivers. Okay, that classification in the grand scheme of things doesn't really matter that much, but I'm kind of a stickler for stuff like that. Drill onlys, that's all they do. They just drill. They're not designed for fastening purposes. So if you go to like a yard sale and you find like an ancient Black & Decker drill, you know, one of those old big ones that have the little pigtail coming off of it, and the dang thing's like that tall and that big, and it's got a tiny little 3/8 chuck on it, the old classic like 1950 style, the ones that like are awesome because they last for freaking ever. I wish they made tools like that now. I really do, but they don't, and that's okay. That's drill only. You know, you pull the trigger, it's drilling. You know, just direct drive. There's no electronics. There's no gearing. You drill. That's all it does. Another example that you're going to see even now in modern times: core drills for drilling concrete. That's a drill only. You're not going to drive screws with that. I mean, you could, I guess, but that would be foolish. Drivers. Milwaukee actually makes a few different drivers. They have a no-hub driver, which I forget the part number off the top of my head. It's actually a 1/4 inch. It actually has a 1/4 inch quick connect chuck, kind of like this guy does, but it's meant specifically for torquing down no hubs. But oddly enough, it has a drill only mode as well, so I guess it is a drill driver, kinda. That was a bad example, but you know, it's a cool tool, so I figured I'd mention it. They have I know they also make a 4-volt. I believe it's 4-volt. It's a tiny little like electronic screwdriver. Really neat little thing. I think it's 4-volt or 4.4-volt. I forget. It's a really weird. It's a specialized thing, and you're not going to see it very often. But it's a neat idea. It's like basically it's about the size of a 6-in-1, and it's got a tiny little motor in it and a tiny little battery, and it just tightens tiny little screws. You know, it's a time saver, I'm sure, if you're a guy that works on electronics for a living. But, you know, so let's talk about the mechanics of this thing, how it works. So, you see this part, the chuck right here, we'll start there. So, you know, you spin this guy around, and that tightens the teeth on it. And you turn it this way to loosen it. Pretty simple. And then you can actually look down in there. You can see the fastener that holds that thing in. That's a reverse thread fastener. So, if you ever got to take one of these things off, make sure you're trying to tighten it. Because, if you try to loosen it, you're actually tightening it, and it won't come off. I mean, granted, with Milwaukee's warranty, you should never really have to mess with that. Anyway, so cardinal sin. If I ever loaned you one of my drills and I catch you doing this, I'm going to take it from you and beat you with it. When you see people hold the chuck and they pull the trigger to tighten these down, do not do that. I will beat you if I catch you doing that. And the reason why: you end up over tightening this, and it causes damage to the jaw mechanism. Okay, you don't have to get it that tight. Most modern chucks are ratcheting. Okay, so when you tighten it, once you start getting it torqued down, it'll start clicking, click, 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 click. Especially on, I know for sure the DeWalt's that I have do that. I'm almost certain these do too. It's a pretty similar style chuck. You know, once it starts to ratchet, that's tight enough. It don't need to be tighter than that. But if you use this to tighten this, you'll over tighten it and you'll damage it. Don't do that. Don't do it. I mean it. I'll find you. Anyway, we'll get off that tangent. So this, I guess this which way does it go? It goes that way. So this has a bunch of different settings on it. I'm gonna keep it turned up this way so we can see them all. So those numbers, 2, 4, 6, 8, all the way up to 14. That's a clutch. Okay, so how does the clutch in this thing work? And what do you use it for? Clutches are used for driving fasteners in situations where you don't want to overdrive. So this is a really crude drawing to kind of explain the concept to you. It's actually pretty similar to how a hammer and anvil works. So you've got these gears, and they're not necessarily going to be shaped this way. I mean, I'm not sure how Milwaukee does it, but I've taken these apart before in the past out of curiosity, and sometimes you'll have like a bearing surface here and a bearing surface here with a race cut into it with notches, and you'll have ball bearings inside of it. These can get really complicated. I just drew it with teeth just to kind of simplify the explanation. So this is under spring tension. These teeth or bearing surfaces, however it's set up, they mate together. And that's what allows you to transmit torque from the motor to the chuck. Okay, so when you adjust that torque setting, you're adjusting how much spring tension's on this system. So when you apply torque to it, if you overcome that spring tension based off the setting you have it on, the teeth will skip. It'll make that awful buzzy, all the clutches slipping noise they make, and the torque won't get transmitted. So that's how that works. That is like explained to me like I'm a kindergartner level explaining it, but that's for what we do. That's all you really need to know. You don't even really need to know that, but it's just it's good to know things. So it also has a drill mode, and what that does, if you go back to this setting here, a lot of times there'll be a crossbar or some other kind of mechanism here to actually fully lock these together. And when you turn that mode on, these are all set up different. I'm not sure how this one works, but it's a mechanism that locks these two gears together to where they cannot separate. Okay, so which means if you got this thing in drill mode, you don't have a clutch anymore. So if you're drilling, pow! That thing could get you. So it's good. So these come with side handles for a reason. You need to, if you got a stud you can brace against, you want to do that. Or if you got a side handle, you want to brace against that. But yeah, that's what that does. And this thing also has a hammer mode, which I didn't really draw it out. I forgot to draw it on here. But basically, what the hammer mode does, this is the most typical way. See if I can draw this out here. That's kind of how that looks. And you've got another gear, gear set up here that links to that. I better put that cap back on that. I don't want to be huffing that in front of you guys. That's for home use. Anyway, so on the hammer mode, when you engage hammer mode, your clutch system's going to be up in here. The hammering mechanism is probably back in here. It's not going to be a part of this. It's going to be most likely here. And now I'm not just saying that because there's a hammer emblem there. Like, generally speaking, that's how it's going to be set up. So basically the way on a small drill like this, the way the hammer mechanism works is you've got a series of ramps, and another gear, there'll be an opposite gear set up here. So that what happens is that these ramps, the other gear set rides up and down on these ramps, up and down, up and down, up and down. I'm going to quit that because I don't want to make you sick. And that creates just a tiny bit of energy moving in this direction. Very, very tiny amount. I mean, less than me doing that. Like it's this very, very small amount of energy. But when you're drilling through masonry with the kind of bits that you would want to use with a drill like this, that tiny little bit of percussive force is all you really need, because it doesn't take much with something like this. Because you're not going to be running big bits with this. I mean, you're talking like 1/4 inch, maybe 3/8 hammer drill bits with this. This isn't going to drill anything bigger than that. I mean, you'll see guys do it, and that's fine, but this is not designed for that. Because again, you're only producing a pound or two of force going in this direction, because those ramps are so tiny, and this thing's just not really meant to do any heavy duty hardcore drilling. Okay, so you'll see on the top here, which is, I don't know why it's set in the middle, that's high and that's low. It's actually pretty stiff. That's a good sign. So there's a gear set inside of this thing. The transmission's going to be right here in front of the motor. And this is my poor attempt to draw a planetary gear set. So essentially, you'll have a center shaft running here. You'll have a big planet gear. And you'll have all these other gears orbiting it to transmit your power to another gear to be on the outside right here. And that outside gear is what actually transmits the power through the system. And that switch on the top of the drill will actually actuate a different sets of these orbital gears, and depending on what set of orbital gears is active at a given time, that determines how your torque multiplication. Because right off the bat, these are multiplying your torque significantly. I mean, because this thing, these brushless motors, I mean, they're spinning at like 20,000 plus RPM, sometimes more depending on the model. So you don't want this thing spinning at 20,000 RPM. It's just gonna screw off into orbit. It's gonna go bah, and no. You need gear reduction for these to work properly, because these spin really, 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 really freaking fast, but they don't put out a whole lot of torque at that speed. So so your initial gear reduction is a very significant one, and then the next gear reduction is even more significant. You know, your load speed. You might only get 250 RPMs out of this thing. So you know 20,000 plus to 250 plus. You know that's a major reduction. But that's how they do it. They do it with a planetary gear set. And on these fuel models, I don't know if these gear trains are made of metal. I would hope they are. I do know that on certain brands, I'm not going to name names, cheaper stuff, Harbor Freight, these gear sets a lot of times would be glass fiber reinforced nylon, or some other type of you know, it'll be sometimes glass fiber. It'll be like a glass fiber reinforced plastic of some sort. A lot of times it's going to be nylon, which in a low torque application, a tool that costs $20 you're going to throw away after the first time you use it, that's probably okay. But on something like this, I want to see steel. I want to see high quality steel. Now, one more thing I want to cover, which I'm going to have to take a field trip to do this, because I didn't think about grabbing it beforehand. We'll talk about rotary hammer drills for a second. This is the only one I have to show this off. And I want to talk about breakers too, and what the difference between a breaker and a rotary hammer is. So on this guy, the motor's down in here. You know, you've got your selector mode here. It's got a chipping mode and a drilling mode, and I think there's even a neutral mode, so you can spin the chuck without having to do anything. This particular one is SDS Max, and let me grab a bit real quick so I can kind of show you how these SDS bits work. Because the SDS bit, you know, leave it to the Germans. So you see that? So you got a slot there, and you got a slot there. So that slot's what actually lets you slide it into the chuck. This is SDS Plus. SDS Max is pretty similar. So when you got it inside your chuck, there'll be a detent that rides inside of this. But what that does is that allows the bit to move inside the chuck. That's what makes the magic happen. Because without that, you don't really have a way to transmit your power into the concrete when you're drilling. Where did I grab this from? That's a 5/8. We'll just set that right there. So on this rotary hammer drill, you know, you've got a transmission inside of here. There's also a hammer and anvil. You know, instead of that weak baby stuff over there, this has an actual hammer and anvil inside of it, so it can actually hit with some authority. So it spins. Where did that grease come from? Wow, it must have been on that bit. So this spins, and this hits. There's an anvil in here. It's knocking the crap out of it. It's good for drilling concrete. A drill like this, you can probably drill maybe 1.5 inch hole with that. I wouldn't go any bigger than that. For like dry coring bits, depending on the design, you might be able to go up to 3 inch, I would assume. But that's probably all you're going to be able to get out of this guy. Pretty cool. So the main difference between a rotary hammer drill and a demolition hammer. Demolition hammers are basically the same thing, except you don't have a drill mode. It's chipping only. A lot of times they're actually the same tool. It's just that instead of having, you know, all the rotating mass to drill with, they take that mass out and they add that to the anvil to make it where it hits even harder. They might even sometimes some brands even use the same exact body. It's just that the internal mechanisms are different. So all the extra weight they're saving by not having to rotate the bit, they're putting that weight back into the hammer and anvil to make it hit harder. You know, then you have your breaker hammers. You know, those are the big T-handle ones. Sometimes they're pneumatically powered. Those are a whole different class. Milwaukee actually is dabbling with that now with the MX line. You know, there's a battery-powered breaker hammer, which is nuts. You know, who would have thought? But yeah, I feel like that pretty well covers it. Well, I can't think of anything else. But if you guys have any questions, by all means, reach out and let me know.